Good morning, Geometry iPad Initiative students. This is Mr. Lane coming again from OHS High School. This will be for section 5.5, which is over indirect proofs, and also has the inequalities in one triangle. So you can read through the objective, read through the why, and number 5, always answer that. And your notes for us. And let's get to rolling on this. Be ready for the secret word at any time. Could show up. 2 points for those who send it to me first. And what is an indirect proof? It is a proof that by assuming the conclusion is false, then you show that the assumption leads to a contradiction. Therefore, the conclusion must be true. Writing an indirect proof, we're going to identify the conjecture to be proven. We're going to assume the opposite or the negation of the conclusion is true. We're going to use the direct reasoning to show a contradiction. Once we have a contradiction, we're going to conclude that since the assumption is false, then the conjecture must be true. A little bit tricky and a little bit tough. I think we have an example on the next page. Let's try and write the indirect proof to show that if a is greater than 0, then 1 over a is greater than 0. So we're given that a is greater than 0. We're trying to prove that 1 over a is greater than 0. So we have to assume the negation of that. So the negation of that is going to be every other possibility. So let's get on to this. We're going to assume that 1 over a, well, what's the other possibilities? Of course, it could be less than or it could be equal to 0. Okay. Let's see. So let's use the given information next. So given that a is greater than 0, so if we multiply both sides by a, we'd have a times 1 over a. That's 1 over a, by the way, is less than or equal to a times 0. Now, if a is greater than 0, then your sign's not going to flip around. So therefore, this would simplify. A's will cross out. We'll just be left with that 1. Sign doesn't change because a is greater than 0. And then 0 times anything is going to be 0. So is 1 less than or equal to 0? No, that's our contradiction. Thus, or how about just this, is false. Thus, a contradiction. So our original, what we're trying to prove must be true. So we're just going to put so 1 over a has to be greater than 0. So something like that would be an indirect proof. We proved that the conjecture was true by proving that the other situation would be false. Let's move on. Regular class would have a couple of these. iPad Initiative students, always on the Lumen website for your problems. Let's see, the next theorem that we have, triangle. This one is has to do with the triangles here. We have if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. Notice in our picture here that the red marking here is going to be the longest side. So our biggest angle is going to be directly across from that. So directly across from it would be angle Y. So angle Y would be greater than any other angle that is out there. And they go in order. So this would be the second longest side. So the next biggest angle would be X. So the smallest side would be this one here. So the smallest angle would be Z. Okay, works the other way too. If this is the smallest angle, then opposite of that's going to be the smallest side. This is the angle in the middle, then the medium length side would be opposite of it. If this is the largest angle, opposite of it is going to be the longest side. Okay, which of these would be the shortest side? So the shortest side is going to be across from the 30, which is the smallest angle. So this would be the shortest side. Which is the largest and the smallest angle? Okay, well the largest is going to be across from the 12, and the smallest is going to be across from the 6. Okay. Alright, I think we would usually have these from the iPad Initiative students. Let's move on. Alright, next theorem here is the triangle inequality theorem. It says the sum of any two sides of a triangle is greater than the third side in length. Okay, which just means if I add any two, it's going to be greater than the third one. And we have the three different situations here of adding two of the sides, which was totaling a greater sum than the third side. So how can we use that? Okay, so we got to figure out on these which ones would be triangles and then which ones could not be triangles. Well, if we add the two, like the 5 and the 10 together, we get 15. That's not greater than the third side, so this one would have to be not a triangle. Let's see, 1 and 15 would be 16. 15 and 15 is 30, greater than 1. So this one looks to be a triangle. 4 and 4 adds to 8, which isn't greater than 8. So this one's not a triangle. Let's see, 4 and 6 is greater than 9. So therefore this one's going to be a triangle. 5 and 12 is 17, bigger than 13. Looks like it's a triangle. 11 and 12 is bigger than 15. Triangle. 3 and 4 is bigger than 5. That one's a triangle. 1 and 2 is only 3, not a triangle. 3 and 7 is bigger than 12, so that one is a triangle. Let's see, 2 and 6 is only 8. That one we can't form a triangle with. Alright, regular class would be doing these problems at this time. iPad Initiative, we're going to move on real quick. It says the lengths of two sides of a triangle are 8 and 13. We got to find the range of possibilities for the third side of the triangle. Okay, so let's click back on here real quick. Well, we could assume that 8 is the smallest, and then we could add the other length to that, and that's got to be greater than, we're going to call 13 the largest angle. So let's see, if we solve this, we'd be subtracting 8. So 13 minus 8 would be 5. So x would have to be greater than 5. Okay. Well, we could also assume that x is the largest side, which would mean that adding 8 and 13 together would have to be bigger than x here. So let's see, we would have what, 21 is greater than x. And then I guess the other possibility would be that the x and the 13 has to be bigger than 8, which it already is. So We couldn't have a negative length, so that one really doesn't count. So our side length has got to be between 5 and 21, so we're just going to write that as one inequality. We're going to face the inequalities to the left. We're going to slap an X in the middle. We're going to slap the 5 here, the 21 here, and that's the possible ranges for that last side. Regular geometry class would be doing those right there. Let's move on. Alright, we have one more example. It shows the figure shows the approximate distances between cities in California. What is the range? By the way, secret word today, castle. Old castle. Just castle though. Alright, what is the range of distances from San Francisco to Oakland? So let's see what we're going to have to do here. So X could be with the shortest side, which is 46, which would have to be greater than 51. So if we subtract the 46, then that would be 5. So X would have to be greater than 5, it looks like again. Well, X could be the longest one, so we'd have 51 plus 46 has to be greater than X, which would be, what, 97? So 97 is greater than X, so we want to write this with X trapped in between 5 and 97 miles. Alright, looks good. Just one problem for the regular geometry students. Then we got the up one, down ones. Alright, looking good. So good luck if you had the box. And this is Mr. Lane signing off from OHS High School. See you on the flip side.